Okay, so I will present on behalf of Peter and Karima a work in progress. It's not yet a paper about COVID-19 pandemic, mitigation policies and mobility. So the title should be maybe more specified on COVID-19 pandemic and mobility. And the title has changed a little bit also from a scale point of view, because in the beginning it was the Netherlands and France, and we said it's interesting to go back to an exploratory analysis from the whole European countries. So the starting point with this work is the fact that the literature on COVID-19 pandemics could be separated in two. The literature interested in the impact of the COVID-19 on our daily life, on our life, economics, etc. Short-term, long-term impact, mobility, co-working, teleworking, residential location, activities, etc. And the other part is the impact all these things or one on the pandemics, on the COVID-19. So it could be mortality or infections, etc. So it's important to separate these two types of analysis. And our interest, and Peter was highlighting yesterday the fact that teleworking, for example, doesn't matter. It has no impact in the COVID-19, for example. So we are focusing in this essay on the impact of mobility on the infection, COVID-19 infection. So if we go back to the literature, since the model of Kermack, SIR, susceptibility, infection, recovery, 1927, there is a great literature on epidemiologic studies, etc., on the spread of diseases in medical, mathematical, geographical science. In these studies, social interaction, social network, physical interaction is considered as an important key factors. And sometimes, and most of the time, mobility is considered as the best proxy for which is playing a great and very important role in the spread of COVID and infection. So everybody knows this ugly nano creator in the right, which is the COVID-19 virus, and the idea is the mobility, the immobility, and mobility has an impact on this spread of COVID-19 pandemics. Yes, and to what extent? And I focus on the term immobility. Stay at home could be a policy, but to be immobile is a fact. We can, in some countries, have the stringency to stay at home, but people go out, okay? So this is the first idea. Then for studying mobility, we know that we made many surveys in each area, agglomeration, in order to produce data, information, and knowledge about the behavior of COVID-19 and how the people, activities, firms are reacting. But we saw that the mobility data, we have operators, Google, some operators, telephone, mobile phone operators, has also huge data. We don't talk here today about the validation of this data or not. We know this is a measure of mobility, but it gives an opportunity to have data, comparable data between countries and regions, etc. And it is, Olivier, for example, was saying that the telework in France in the beginning was 50%. This is a national survey. In mobility, data is more important, so it's a little bit sure estimated. But it's okay. If you compare the different countries or regions during 2 years, it's okay. So let's see what are the evolutions. So this aggregated and anonymized data is used to feed a dashboard. I cite Richie, for example. Karima and Peter done a great job in the Netherlands about the dashboard and the analysis, updated analysis of the spread of COVID and mobility and stringency. It's also used to assess the impact of policies and policy measures, stringency, etc. And I gave here some recent paper based on different techniques, econometrics, machine learning, etc. So things are moving and it's very dynamic. In our case, so we are trying to explore, to investigate this impact of mobility on the infection. So we use the daily open data, famous Google data mobility based on the points of interest. We are here today. Those who have an Android and they activate their historical position, this data go directly to this database and could be used at different scales. We don't have access to the detail level. It's different when I use my tracker, GPS tracker, or we can, we make our cuisine, etc. But here we have data. We don't know really about this data, but it's available. So, for example, we don't have information about those who have an iOS system, but we suppose that it's quite the same. We use a panel of 29 European countries from covering the period of 12 March to the 2020 to 31 August 2021. So Cyprus is excluded because of an availability of data on several variables. So to have an idea, maybe most of you knows this data. So we are interested in the new cases. We don't use the mortality. We wonder what are the role of mobility in the evolution of the new cases, the daily new cases. So we use the mobility trend, which is measured first about the time we spent at home. So we take a baseline, which is from January to February, during 5 weeks, as a baseline, and we look the variation of the time spent at home. It could be plus 50% in the first lockdown, and etc. So this is the first variable, which is the time spent at home, and it's considered as the variable of immobility. We have the grocery pharmacy stores, so it's based on the number of visitors, the number of active who commute to the workplace, the parks, the transit stations. It takes into account public transport, but not only the infrastructure of transport. Retail, recreation, and this is the source. We have it is an open data. We use also some policy measures, indicators, like the famous stringency index, containment index. And to have an idea on this stringency index, it's composed of 11 measures. The closing of workplace, school, public transport, the gathering, public events, and some Florent, for example, was given some examples on the isochrone of mobility. In the beginning, for example, in France, we couldn't move over 100 kilometers, and after this, this thresholds were changing, and we have also the stay-at-home policy, which is in 4 levels. We have a strict one and less strict, etc., until the 4th one. So this is about data. For the model, we use a simple pooled mean group autoregressive distributed lag, so PMG RDL, and for some descriptive statistics. So we have the COVID new cases per million, which variate from 0 to 3,000. And then the other indicators are changing from 0 to 100. Okay, it's a percentage. Of course, some variables are correlated because the immobility is correlated to the fact inversely correlated to the fact to take buses, etc. So we have to make choices to retain just some variables. Stringency and containment are 2 indicators. Yes.
This one was just 1 point on time.
Which one? This?
Yeah.
Yeah.
It's 1 point.
It's 1 point.
The 1 point is in time.
I didn't get it. Sorry.
I said you don't have a time series.
No. We have a time series from. Yeah. It's just a pooled one. I can give the descriptive statistic of the 29 countries, from 1 to with the variance between and within. Okay, so this is a pooled statistic descriptive. So we taken just the stringency index because it's used in the literature, and we have some point of comparison. So for the use of this the RDL model, we have some variables who are stationary at level 1, 0, and others at first integrated order 1. So RDL could be interesting. It's maybe not the best model, but for the battery of tests of co-integration, so are significant. Both are significant. Here is the results. And we will, as the Haussmann test gives better to privilege more the MG mean group model than PMG, because we have great heterogeneities between countries. So what is interesting in this result, and I will focus on the long-term result. The first one is stringency has a negative impact, but it's not significant for the 29 countries. The other first most important result is residential. Immobility has a negative impact on the spread of COVID-19. It's intuitive, but we've taken grocery. Grocery, the variables we have dropped retail, etc. But it's a kind of shopping. Variables of shopping have a positive impact on the evolution of new cases. Here we have a counterintuitive sign. Workplaces has a negative impact. The more we have people who commute, the less we have the spread of the COVID-19. We try to manage that. Okay, and the other one is the parks also. So the more we have the park visiting by car or by bike, or I have the connection with discussion of yesterday, the less we have the the spread of COVID-19, and in order to have a more clear idea about this kind of so we have endogeneities here, okay. So what we have done is to make a Granger no causality test to see the sense of causality. So the first interesting result is that immobility has an impact on COVID-19 spread. Okay, this is in this sense. Shopping, the group shopping activities, has an impact on COVID, but also COVID decrease the mobility and the travels linked to shopping increase COVID. We have seen that the sign was counterintuitive, but in reality, the workplace, the commute into the workplace is the consequence of the COVID-19 and not the inverse, as we can see here. So the stringency index, we said that it's not significant, but the problem here with this variable part, and what I think is that behind this variable we have the question of weather, temperature. Some papers shown that the more the temperature is high, the less we have infection. So I think, as we know, people also go to parks when the weather is fine. They don't go to parks in winter. Okay, so we have this cyclical. The solution is to bring data on meteorology, to bring data on the weather and to put it on this model. We don't have this data for the moment. So we have the results that I explain in this moment. But behind this pooled data and pooled this results on 29 countries, we have heterogeneities between countries. Okay, France and the Netherlands are different. Okay, and people are also behaving differently. Okay, so if we take an example of France, so it's following the same model. Okay, we have the immobility with a negative impact, grocery, etc. So it's following the. When I go to the Netherlands, nothing is significant. Right? Okay. So nothing is significant. So we can, sometimes when we are describing the COVID-19 and mobility, etc., we are always given the point of view of the country where we are, generally, or yeah. So it could be, there is some differences. If I take Portugal, and we are in Portugal, so the immobility is not significant. It's the stringency index. Policy has a negative impact, and so this is we find this in some papers. So it's quite quite different. And if just to have an idea about the evolution of the immobility, the residential, the time spent at home, and the new cases per millions. Here we have France. On the other side we have the Netherlands. We can see some evidence here in France, but not in the Netherlands. Okay. It's just to have a small idea about that. So the impact, yes, but yes, but it's heterogeneous. So this is the first step. We have to do some studies on this, even in this data, maybe to have to bring other data on weather, etc., in order to have evidence from from European countries or other countries. So we have yes, but it's heterogeneous among countries. So the conclusion is not yet. Yeah, I tried to perform my conclusion, but well, that's it. Thank you.